Okay, we have 21. All right, I think I will get it going. Hi, Tim.
Hey there. Hello.
How are you?
Good. How is you? How are you?
Good, good, good. So, so we're gonna continue talking about GitHub. I think we talked about what it's like on GitHub, and we talked about a couple of files. So I'm gonna just review with you, and then we're going to come back to our local computer. Right, so let me present you my oh, the people still come in. So this is github.com. Okay, let me get whoever is waiting there. Who's waiting to get in? Okay, there you go. Oh, okay. Okay, here is a view of my GitHub account. So I logged in, right? I logged in, and then you see I have a whole bunch of repositories or repos. Now you're gonna need to create one for your project or for this course. Okay, so what I like to do is I will create a project for like a repository for each project. Okay, I will create a repository for each project. For example, I will say create a new repository. Okay, then automatically you see your username is already there, right? That's mine. And then you put a repository name. The name has to be unique because it's like a folder name. It has to be unique to identify it. So I would say CSE 248 for, say, for 2020 and project one, for example, or some like a trail app. Okay, so you can do whatever you want. I'm just saying that I would create a repository for each project, substantial project. But if you just want to store your work for a course, you could do that too. So I have a CSE 248 for this course. So all the code I do for this course is uploaded there, okay? Now for project, I tend to, especially projects that are substantial, I would put it into a separate repository. So in the future, I can share with someone who wants to look at my project rather than share the whole course. Okay, so course is more like for myself. In this case, for the course for you guys as well. But a project will be for some, for someone who say who's going to hire me or who's going to look at my work. So so there you go. So that's my repository name, and it has to be unique. So this name is available because it's never used. Now here you can put a description, what this is about, right? Usually you can put a brief description. So it's like one line, people know what this is about. Okay. And then you should make it private, right? Because for all your project, at least for this course, you should make it private, because in the past we see happens a lot. Some students will go to another student's public repository and copy the code for their project. So this way we get the exact same, code, exact same project. So you want to do private. So this way only you and person who you choose who can see the code. Okay, so you protect your repository. And then you can initialize the repository with a README file. README file basically is a text file. Okay, so you can use a text editor to open and edit it. And that file is for you to describe in detail what this project is about, or any kind of to-do list, list of bugs or things you want to explain to people potentially who want to contribute to your project. Okay, so there are a lot of people do like open source projects. So say if you have a good idea, you would start a repository and then you would write a README file. So other people could, if they're interested in your project, they could join you and work with you on the project. Okay, so that is the README file. The README file uses a language that's different than just regular text file, and it's called a Markdown language. Okay, MD. And that language is similar to the markup language, like HTML. HTML is a markup language, and this is Markdown. So it's a different syntax, but the idea is the same. Basically, you use a bunch of tags to format your text file, right? If you use a regular text file, like a notepad, you cannot really format it. You cannot change the font, you cannot change the size, you cannot change the alignment. You can't really set those things. Basically, it's just pure characters, right? Now, with markup or markdown, you can actually change the format, okay, the font, the alignment, all that. For example, what you see on my screen right now is HTML, right? That's a web page. And that you can already see some are bolded, some are regular. You could have italic. You can have even you have symbols like this. You can, so this is you have links. You see this links, right? When you do a regular text file using Notepad, right, or TextPad, they don't support this kind of format. You also have an alignment. You see, this is an indentation. That is part of the format, right? So text file cannot do that. So you have to either use the markup like HTML in this case, or you can use a markdown. That is another way of doing the same thing. Okay, so if you want to modify your README file, then you have to make sure you follow the markdown syntax. And you can do a quick Google search. You'll find all the syntax for markdown. Okay, that even you want to make a link to the web link URL, you can all do that. Okay, so that's README file. It's meant to explain things in detail. So it's a very important file to tell people what your program is about. Okay, here the second one is add.getignore. Getignore is another text file, and this text file allows you to enter any file or types file that will not be backed up, will be ignored, will not be backed up into the internet or to the cloud or to GitHub. Okay, so for example, when you have some kind of temporary files, right? Those files usually have no place, no reason, no need to be backed up. Okay, and other things like the bytecode file, right? They can be produced as long as you have the regular Java source code file. So those you don't really need to back them up, right? To back them onto GitHub. So you could ignore those. You can ignore those. You should ignore those. Okay. So GitHub provided a lot of templates. They believe that those are good candidates to be ignored. Okay, so for every language, you can see they have a template, and then you can work off the template to say, okay, this seems to be a good idea, or this needs to be backed up. So you can change, but it does provide some kind of a starting point. Then Java is on the list. You see, Java is on the list. So we can just select Java, and then you can actually see later what are ignored in recommended by GitHub, and so you won't back up those. And we don't need a license because for small operation like individuals, small companies with a few developers, GitHub is free. But if you are a large corporation, you have tens of people working on the same repository, then you're going to have to purchase a little license. Will cost you about $20 a month or something like that. So you can see the programming world is changing quite interestingly. We used to have our own GitHub, our own Git server. Okay, every company, especially software company, they want their own Git server. Now you don't need, you just pay another company for $20, and then they will do all the backup and all the maintenance work for you. So so all this thing is like a electricity, like a service. Okay, so you could just pay a monthly fee, just like you pay for the electricity and then for gas. Okay, so otherwise we don't need a license because we're a small operation. And then we could create the repository. Okay, here's a repository. Now here's a repository. That's the name that I gave earlier, CSE 248 fall 2020 trail app. And it tells you this is a private repository, right? And then there's a few things to notice. First of all, you see the two files are there. One's readme.mxmd, another one the .git ignore, right? Now the .git ignore, because it starts with a dot, so this is normally a hidden file. So if you go to your computer and you want to look for this file, you have to make sure that you use the ls-a. A means all, right? In order to see the hidden files. Otherwise, the .git ignore will not be visible. But README is a regular file, and then also notice that README is all caps, right? So that's just the convention. Whenever you go to someone's source code, they typically all have a README file, because README file gives them a chance to explain the structure of the application, or the important things about application, the purpose, so on and so forth. And so they all use capital README, capital letters. So that is something, that's our convention. And also you notice the extension of the file is .md. That stands for Markdown. So the language, the syntax is a Markdown. Okay, so we can take a look at those files quickly. The first one is open it up, and you can see that is a README file. It's really just a text file, except that you see there are certain things eliminated, not got backed up. So for example, star is a wildcard dot class. So any kind of bytecode file is eliminated. They will be skipped. They won't be backed up. Okay, again, the reason is because as long as we have the .java file, we can always reproduce the bytecode file. So there's no need to back up both. Okay, so also the log file, any kind of log file, because you see the star, you can see this, right? I can blow it up a little bit for you to see. Okay, so you can see that star means that's anything, is a wildcard. So any file doesn't matter as long as it ends with .log. Okay, as long as it ends with .log, then that means will be skipped. Okay, it won't be backed up. And then the BlueJ files, I don't know, some of you might have used the BlueJ. Some, I think the Grand campus, they use BlueJ exclusively. Is a kind of equivalent to like Eclipse. Okay, it's a IDE. You have to kind of learn to get used to using it, I guess, just like a Eclipse. And it's hard. It doesn't do much auto correction. It doesn't do much syntax detection. So if you make a mistake, the BlueJ won't tell you. Okay, if you type missed a parentheses or missed a brackets or curly brace, BlueJ won't tell you. Say something's missing until you run the program. It crashes and then say, "Hey, something's wrong." Then you're gonna go find out what's wrong. So they believe somehow. Some people, not this, some people believe that's a part of the training. You should be able to, mentally do all this matching and then make sure there's no typos. And but a lot of people don't think that is necessary. Okay, so that's the difference. Anyway, so this is some kind of a temporary file as well. So they don't recommend to be backed up. And here is for mobile. Okay, mobile tools for Java. Mobile is meant for like a mobile applications, right? Like apps, like for phones. And then Java uses called a micro edition, ME. Okay, now the Java we use is SE, stands for standard edition, right? That's for like Windows and Mac. But if you want to do phones, like a mobile apps, they have a separate Java JDK, okay, development kit, and that is ME, that is a micro edition. Okay, so that has some kind of temporary folder that is not recommended to be backed up, right? So again, you can see anything you see something end with a slash, that means this cover the whole folder. Okay, that folder will be ignored. And then whole these, obviously they don't have the slash there. That tells you those are just the files. Okay, so any files starts with whatever name, ends with .jar, .war, nar, zip, and tar, .gz, and rar. So those are all package files. Package files are files that are compressed. They're compressed. Then it's like we used to submit our projects using zip. Remember, right? I asked you to submit the entire project using zip. But you could also, that would be this case, right? It's packaged into one file. But they can do other ways. You can do tar.gz, and then that's Linux way of doing it. It's tar. TAR stands for tape archive. 20 years ago, that was 30 years ago, is used very common, almost exclusively. TAR is one type of algorithm to back up or compress your files and folders. And GZ is an algorithm called GNUD, GNUD, GNUD. It's an open source algorithm also for compressing files and folders. And then there's another one, RAR, that's also. And then these are all Java compression algorithms. Like a jar is a Java archive. So it's a native Java way of compressing files and folders. And war is a Windows version. That's where the W comes from. The Windows version. So, and the general one is .jar. That's a Java archive. The archive means backup, right? And then there's a NAR for network, and I don't even remember what the EAR is, but it's not important. Okay, there's different algorithms to back up your files and folders. And then there's a bunch of other things, like this has to do with virtual machine crash logs. So when you run the program, sometimes if there's a problem in your program, the program will crash, right? And then in that case, the virtual machine, because this is actually the virtual machine running your program. You understand that, right? So here, there's one term very important. I hope you will remember it. That's type of error, right? When you run the program crashes, that kind of error is called a runtime error. Runtime, because you're trying to run your program, then crashes, right? So that's different from compile error, okay, or compiling error. Compiling error is when you type your code, when you write your code, you get a red line, like curly line underneath your statements or words. Then that's like a regular syntax error. Syntax error that is detected by the compiler. Okay, compiler will detect those and then give you a red line and a red curly line underneath the suspected statements, right? You've seen that a lot. Okay, so all you have to do is just correct the statement and then you are good to go. However, so those errors go to compiling error, and those errors are easy to detect because you really cannot compile unless you eliminate those compiling errors, right? So, but sometimes, sometimes the program, the compiler will not see any error at all. So there's no red lines, everything looks fine. Okay, you can even compile it. When you compile it, basically you produce the bytecode file, right? Right, when you compile it, you produce a bytecode file. And then the program crashes when you actually run this file. Okay, so let me just make sure you know this. So let me give you a quick diagram for that, because I think that's just very important. So when we write our code, we call that .java file, right? Those are source code file, you know that, right? It's like a text file. We do it in Eclipse. Okay, so now when we run the file and run through a compiler, and then we turn that class Java file to make it a .class file. Okay, so class file is also known as bytecode file, right? Bytecode file is type of machine code. Is a machine code. So machine code is meant for machine to execute, okay, to use. Okay, now what you need is you need a Java virtual machine, JVM, to actually execute the machine code. Then you get your result. Okay, then you get a result. So when you write Java programs, you have to go through two steps. When you finish the Java code, you have to compile it. Once you compile it's finished, you produce that class file. Then you're going to use the Java virtual machine to actually execute or run the bytecode file, right? Because Java virtual machine is a machine, or it's called a virtual machine. That means it's really the software simulating your machine. Okay, it's not really a physical machine. It's actually a software program that is simulating a physical machine, and it understands bytecode. Okay, go ahead.
Brian's still waiting to get in.
Who?
I don't know. Brian, Y, Bryan. He
But
said he would.
he's not using the right meeting code,
He's
because I
not?
didn't see anything. Yeah, he must be using a wrong one.
Okay.
Can you send him the right one?
Yeah, someone else put it.
Because nothing popped up like requesting an entry.
Did I pin the wrong one? I think so. I don't know.
Right.
He's been asking since the beginning of class. I got confused because there's another Brian in here.
Yeah, that's me.
Yeah.
I don't know.
You're right. We're lucky we have two Brians. Otherwise, nobody would know who Brian is. Yeah, there you go. So
There we go. He's here.
what?
So there we go.
Yeah, so he was using the wrong code.
I don't know why, but like I was using the one from the first email, the one that I always use.
First email means the first day of class. We changed that.
Hold on. I don't know. Let me see when you sent it.
Yeah, doesn't matter. Now you have the right one. Just keep this one, delete all the rest.
Yeah, I was waiting since like 12.
It's
I'm
15.
also
sorry.
pinned in Discord, so if you ever need that
Yeah,
as well.
I
Yeah,
couldn't go
thanks.
out and look for people, you know. I couldn't go out of the room and look for people outside because there were too many people outside. All right, so you just have to remember this code from now on. Delete all the other code. Okay. You can use a little program I use. I like it. It's called a keep. And then that is synchronized with the phone, with all your devices, and then anything you know you want to save, you can save into that little app, and then you can pull up from anywhere. You're good, Brian?
Yeah, I'm good. I'm paying
Okay.
attention.
Okay, fine. So so that's what happened, right? So that again shows you that there's no need to back up the class file, because as long as you have the Java file, you compile it, you always get the class file. That's why we want to ignore this. There's no point to back up the class file. Also, you understand the class file is much larger in size than the source code file, almost like 1 to 10. You know, like that file is like 10 times bigger than the source code file, because our language in Java, the syntax we learn is a high level language. Okay, is more descriptive, more dense, more like a human language. And then once compiled in the machine code, the code has to be dumbed down to the level that a machine can understand. So you have to do a lot of small breaking down and breaking down into small pieces for machine to be able to digest. So that's why the bytecode files tend to be much larger than .java files. So that's why another reason that we don't really need to back up this the bigger file. Okay, so that's the reason I was talking about. Okay, so these are well, when the program was able to compile, that means you already have you will produce that class file, right? Now the JVM is actually running the bytecode file, and at that moment, the program could potentially crash. Okay, that moment, that kind of error is called runtime error. That's called a runtime error. Okay, the runtime error are the errors that hard to debug, because it happens in certain conditions. Sometimes it doesn't happen even. So it doesn't give you a red line telling you what's wrong. So that's why it is the Eclipse will save such a file, or Java will save such a file, hs_error.pid. And this file, as long as the file starts with this, you see, and followed by the star, that means followed by anything, okay, which basically followed by a number, very complex long number. Then when that happens, that file will contain the reason, you know, the computer crashed at runtime. Okay, but it's hard to decipher though, because the machine is a virtual machine code. Okay, now PID stands for process ID. You don't have to worry about that. So that is the git ignore. Okay, and now if there's something you don't want to back up, you could add stuff into that file if you want to. Okay, you can just go to here, you can add it, and there's a place to allow you to edit, and you can see there's a place to edit this file, right? Edit this file, so you can click on this, and then now will allow you to edit the things. So if you don't want anything like a star.pdf, so that means PDF files will not be, any PDF files will not be backed up. Okay, or if you have JPEG files or movies, you don't want to back up, you can just specify, whatever you want. So that's how you edit it. And then when you're done, you can just save it. Okay, and when you save it, then now you have to make a commit. Commit means you want to save it. Save it is another word. It's called commit in Git. Okay, that means you want to commit that change. Is another way of saying save that change. Okay, so you want to commit that change. Now, when you commit a change, you may want an optional description. What you did, what you try to do, what the purpose of it. You can say, oh, added PDF files to be ignored. Okay, so for example, that's a description. So this way you know what this commit is about, is a message. So that's important. Okay, so understand the idea of commit changes, and also understand the need of having a little message attached to each commit. Okay, commit I know is a verb, but also people use it as a noun. That's for each commit, for each save. Okay, so now you also notice when you commit, what you want to commit to. We said we commit directly to the main branch. It turns out that right now, when we just create this repository, we only have one branch, and the branch is called a main branch. So you can see that's a main branch. Or you can say, I want to create a new branch, okay, for this commit. So this is what happens. Let me show you what that means. Okay. Now, when you write the code, right, you save some files, right? And then, so they're made of like a timeline. So this is your code. This is your Java code, for example. And then as you making changes, making more commits, okay, so you have different versions. Okay, so this is version 1, this is version 2, and this is version 3. So as you make changes, you are taking snapshots of your code. Okay, like restore points. Okay, so this is a timeline. Okay, that's a timeline. Say go from left to right. Okay, so initially the earliest one is the first one, and then as you go, when you make changes to the code, you take snapshots of your code and store them into Git or GitHub, right? Store them. So the point of that is you can go back to it any moment of time, right? So say you make a bunch of commit, right? So you have different versions. Okay, and then one day you decided that a lot of things changes you made, are useless. Okay, you decided that those are bad idea. Then what you can do, you can go back to early version very easily. So you can say, I'm here right now, right? You decided all these are just a waste of time. You did all the work, you realize that was a bad idea, that was not meant to work that way. So you want to abandon all the changes. Okay, then what you can do is you can revert back to any snapshot, to any version you like. So this is called a version control, right? You can control going back to any version and abandon all the changes since that version. Okay, that will give you kind of a restore to an old version, right? So you can already see that the benefit of being able to do this. For example, if you say you have a code, you have your trail application, right? and then you are making progress, and it's working right now, right? Then you decided you want to add a new feature. For example, you want to add all those stops, intersections to allow people to search for the shortest path or the possible path, whatever. So you keep on working on this. You continue make more changes, and then one day you realize that was a bad idea. The idea you had is not working out, right? So what you can do is just you can revert back to the old one, then you abandon all this. Okay, so that's one reason we have this software. It's called version control. Another version is when you have a product, even, right? Say you work for, I don't know, let me make, let's say QuickBooks, QuickBooks, right, for bookkeeping. Okay, or yeah, just bookkeeping. So say you have QuickBooks. Now, QuickBooks can have many versions, obviously, right? Like all the software. What they do nowadays is every year they sell your version. Okay, they don't really sell one version that you use forever, and then they keep on updating it, and then they charge you every year, right? So say you are the tech support, right? You're the tech support, and you are answering phones. Now people call you for support. They may say, "Oh, I have this 2020 version," or someone may say, "I have 19 version." Some may say, "I have 18 version." Okay, so you are the tech support, right? Basically, your computer has to have multiple versions in order to help customers who are running different versions, right? So now, because you have a version control, you can easily go back or jump to any version on your computer, because your computer has snapshots every version. You can go back and forth, right? So that's another purpose. Okay, now, so now going back to what is the main branch and the new other branches. Say, so when we create our repository, okay, so that's our main branch. Okay, that's what we just have, right? We just created. Now you can continue working on your main branch. Okay, so you have a new updates and improvements, so on and so forth. So so that's fine, right? That's fine. Now maybe you're multiple people working on this product. That's possible, right? Like you have a team working on this on your trail program. So you don't want everybody is working on the main branch, because potentially people have different ideas, they have different ways to implement things. So potentially they can cause conflict, right? So I'm changing one, say I'm changing the trail class. Another person is also changing the trail class, and they use different variables, different algorithms, writing different methods. So it could be a mess. Could be a mess, right? Because they all try to contribute. They try to implement something to improve the program. So what you should do then is not to allow people all using the main branch. Okay, because then you're gonna mess up the whole main branch, right? And it's very hard to consolidate later, right? Because there are many people, they have different versions, different ideas, different code, different styles. So it is a mess. Okay, so what you want to do is instead you want to keep your main branch untouched. Then you copy your main branch to make a new branch. Okay, so you make a branch 1. Another person will say branch 2. Another person will be branch 3. So there are 3 developers. They're all working on the same program. Then each of them will actually make a new branch for himself or herself. Okay, you got it? So then everyone's to work off their own branch. So they will start to have their own timeline. You see, they have their own timeline. They're making their own snapshots, their own improvements, and so on and so forth. Okay, and then hopefully, the final version of the 3 people are somewhat compatible, right? say you're working on different methods, you have different, the ideas are compatible. If that's the case, then they can merge into one version. Okay, you can merge into one version. And then they can test the version and all believe this version is good, right? Is good. They want to adopt it. They want to adopt it. When they want to adopt it, then they can merge this is the merged version with the main branch. See? Now they merge this thing with the main branch. Now, because we already tested this branch is working, when we merge with the main branch, then we say, okay, so now the main branch will work, okay, because it's already tested ahead of time. So before this, the other branch works, the main branch is not touched. Main branch is kept intact. You follow me? So that's the strategy. That's a strategy. So that allows a lot of people working on the same project. That's why this program is, this GitHub or Git is so important. You cannot live, like a life of a programmer without using it. Okay. If it's just in the one person, you can use to have a branch to work on a feature just for yourself, or you can use this as a backup tool. Okay, you don't have to manually remember to do a backup every night. You just back up to the server, take a snapshot. So that's one person. When you have a group of developers, then that's even better. Now you can work off different branches, and then you merge different branches, and then before you merge everything into the main branch. Okay, so let's go back to the original the page we were looking at. So here we just commit directly to the main branch. We don't have a new branch at this point, right? But we could. Okay, you could create a new branch, and then you have to say, okay, what branch you want to call it, right? So you can put a name as the new branch, and then you start work off the new branch. By putting on the new branch, whatever name you give to it, then the original main branch is not touched, is not modified. Okay, so whatever you change is going to be only changed on this new branch. So so this way, maybe someone feel more comfortable, right? Especially if you're new, is a beginner as a programmer. So you say, okay, I'm working on my little own branch until I'm comfortable and happy. Then I will make a pull request. Pull request means, hey, I did my branch. It seems to be good, and we'll send a pull request to whoever owns this repository. Say, hey, do you want to consider incorporate my changes, my branch into the main branch? Okay, so then the person who's in charge will look at your branch, experiment it, test it until he's happy or she's happy. Then this new branch can be merged with the main branch. Okay, so that is the idea. So we don't going to do that yet. So we just say commit directly to the main branch right now. Okay, so just like commit. Okay, commit. Now this will be our second commit, because we had one commit before when we create this two files. When we initially create our repository, that was the first commit. Now this is the second commit. This is the latest commit, is the one we just did. You notice this is a hexadecimal number, right? Is it a hexadecimal number? E919F67F. So what happened is every single commit has a unique ID, okay, to identify it. So this is why you could go back in history, right? Because every commit has a unique ID. So you just have to, which commit ID you want to go back to is guaranteed that to be the unique one. That's the only one to go back to. Okay, so you notice this is very long. In fact, this is just a part of this commit ID. Commit ID is actually much longer than this. Okay, now you can look at the history as well. To the side, you look at history, the commit history. Now you notice the two commits so far, right? One commit is the initial commit. That's 33 minutes ago, believe it or not. That was 33 minutes ago. Seems to be very quick. Okay, that was the commit ID. See this? It looks different than this one because they require to be unique. And here you see that's 33 minutes ago, and this is the most recent one. It's 1 minute ago. That's when I modified that. The PDF file, I guess was it. So that was my second commit. Is my latest commit. So this is the ID, and you click on it, and then tells you what you did in that commit. So all this is what we created. See in that commit, right? So we can go back to, we can browse all the files and look at what was committed at the time. Okay, and or you can go back and look at the most recent commit, which is the one I think was we added something and then we deleted it. So nothing. I thought did I add a PDF? Here. So I changed this, but I didn't really. That's the way I added the PDF. Remember .pdf star.pdf, but then I deleted it. There's really nothing gets added. You see, but there's a mark there that I attempted some change, so that's why I made that commit. But if I save that star.pdf, then that will be here. That will be highlighted. You see the greener? That shows you that's what changes I made. In this case, nothing. I was there. But everything else is the same. So that tells me what it was. Okay, let me go back. So I have 2 commit history in the history. Okay, there you go. What else? This browse the change. That's where that's the README file. So it's really nothing there. It's all verified. So it's cool. And you can order them newer on the top or older on the top. That's just sort the commit based on date and the time. Okay. So this is very, very important. Okay. You have to understand. Okay. So far we have 2 commits. And then we can go back, look at the code. So that's where we have the code. We don't really have anything other than the 2 files. We don't have any code yet. And we could add files if you want to. This is only one branch. You notice that one branch, that's the main branch. And you click here, you can create a new branch if you want to. So you can create a new branch, but we're not going to do it here. We're going to do it elsewhere on our computer. Okay, so I think, there's one more thing I think you need to know. You see the code here, right? You see the code here? When I click on here, you see, it opens up this, right? You notice there's a web link here, okay? https://github.com/my username. You see this? Then followed by my repository name. You don't really see it. So I'm going to copy it here. Watch. I'm going to copy it here. This is very important, because that's how my computer at home, or right now in front of me, could connect to this cloud location, to the repository on the cloud. Okay, notice again, I'm going to bring you back to our the context of the discussion. Here, notice we are on the cloud. This is a cloud. This GitHub is somewhere on the internet, right? Okay, ultimately, that location has to be linked to our local computer, right? So this way, any change I made on my local computer, any files I save on my local computer could be synchronized with the remote cloud location, right? To the GitHub, basically. So right now, what you see is all on the cloud. Nothing is on my local computer. I'm using my local computer as a browser to see what's on the cloud. Essentially, that's what it is, right? Okay, here it provides the link that I can use to connect to this location on the cloud. Okay, I need this web link so I can show you. I can show you this. See, that's the web link. I just paste it now, you see the whole link. It tells me where it's located. It's on github.com. It's on this user account. That's my user account. And this is the name of the repository. And don't forget, you add .git behind it. Okay, so that is the web link uniquely identify that repository. Okay, under this particular user account. Okay, so so that is something we need later when we try to hook up our local computer to this location. Okay, we need that web address, in other words. Okay, so that is this one. Okay, this is also a place you can download zip. Okay, that means when you click on this, you click on download zip, then everything I have under this repository will be compressed and download as a zip file. Okay, you can do that. So you can download everything in one shot. Okay, also you can open with GitHub Desktop. GitHub has a little app, little desktop application that is GUI based, graphic user interface based, to allow you to see everything from a local computer. You can use a drag and drop, which is convenient to some people, but tedious to others. So it's optional whether you want to use it or not. Personally, I don't use it, but you could. Okay, but the main way I use it is use this HTTPS, that web link, then link my computer to this location. So I would use the first option more often than anything else. Okay, so this web link is very important. So I need this place to show you the next step for me to link my local computer to this place. Okay, good. All right. Okay. So any questions at this point? Anything you want to ask? Anything confusing? Okay. So far today, we did everything on GitHub, on this cloud.
I just have one question. Now, how do we connect a person? Like, how do we say this person can commit to it, look at it, or stuff like that? How do you do that?
Well, right now, mine is private, right? So nobody other than myself could access it, regardless of from a computer or with a browser. So because I protect it. So you have to log into your account in order to see the content, see this content. Okay, because it's private. Now, if it is not private, public, then everybody in the world can see the content, but can only see it. They cannot change anything. Okay. Now, in order for them to change something, okay, you have to add them as a collaborator. Okay, there's a place here. You can add as a setting. You see, this is my repository right now, right? So I want to bring you back to where I am, which is the repository, right? So presumably I'm gonna have my Java code here, which I don't have, but soon we will. And then you will see that there is a settings here, right? Settings here, and only the owner can access settings. Okay, you have to log in to your account. Okay, so you have the settings, and you click on settings, and there's a place that allow you to add manage access. Okay, manage access. Then you will double check, make sure I'm the right. I am the owner. So okay, double checking. I don't remember if I no. No. Ha. Okay, so now it's confirmed that I am the owner, right? And then who has access, and then you can manage access. You can invite a collaborator. So if I invite you, then that means you are able to not only see, but also change and make commit. Okay, you can create your branch, like we talked about before, and you can start to commit to the same code base, the same repository. Okay, so for your project, for this course, you should make it private. And at some point, when you are ready to submit for me to check. Then you'll invite me as a collaborator. Then I can go and view it and then grade your project. Is it okay? Yeah. Okay. So you can invite a collaborator. When you invite a collaborator, you can put down that person's GitHub account name in there because that's guaranteed to be unique, or you can put that other person's email address there, and then that person will receive an invitation. Okay, invite. And once I receive the invitation, or whoever receives the invitation, then the person will become a collaborator. Okay, make sense? Okay, of course, you can also take that person away from a collaboration as a collaborator. Then that person will lose the privilege. Okay, so that's place. Okay, another thing that is interesting and useful is at this point there is a action, I believe, and then at the way in the bottom, not this place. Setting, manage access, security analysis, branch, notification, deploy, secrets. No, I don't think options. They changed this. I think that's the place. Yes. So you click on options. There's a place you should know. It's hidden so deep. So that's why I want to show you. And all the way to the bottom, you see the danger zone. And that's a place you can change the repository visibility. You can transfer ownership, right? Say you want to give this ownership to someone else. And you can archive this repository. And most importantly, you can delete the repository. So that's a place you can play, right? Since many of you guys are just created this account, you want to play with it. This allows you to play, any way you want, because in the end you just delete it, right? Easy delete it. So this allows you to kind of consolidate and allow you to transfer and control your repository, or even in the end delete the repository after you play with it. Okay, so that is under options, under settings, under options. And the very bottom there's a danger zone. That's a place that allow you to delete. Okay, so I'm not going to delete it yet, and then because I need to connect my computer to that repository in a moment, so I don't want to delete it yet. You got it? Okay, any other questions? No. Okay, if no questions, then we're going to coming back to my own computer. Okay, I'm going to come back to my own computer. So here's my computer, and then I already download and installed a program called a Git Bash, right? I think I told you need to download a Git, right? So you download a Git, regardless you use a Windows or Mac, and you install it. And once you install it, you go to Mac. If you have a Mac, you go to Terminal. Okay, Mac has a terminal, right? The black screen where you type your command, and then you can already use it. That way it has Git Bash installed there. But if you're Windows, then there's a Windows app called Git Bash, and then you can use that. So I will just, since I use Windows, here it is. So here is my local computer, right? This is my local computer. Right now I'm at this place called the tilde. You see the tilde? That means that's my home directory. That's home my directory. I can pwd shows me that's my home directory, and the C drive users Chenby. That's my home directory. Okay, so if I want to go to my documents, I just cd documents. So now I'm on the documents. See, cd means change directory. If I want to go back to my old home, just the dot to bring back a level, I'm back to my home directory. See that? Someone else arrived. So CD allows you going, back and forth between directories. So in other words, you use CD, stands for change directory, to navigate on your computer directory tree. Okay, so for navigation. So now here's the place I want you to think about how you want to connect your computer to GitHub, right? Because don't forget, your GitHub is going to have a lot of repositories down the road, right? Because all your projects, all your courses are going to be all on GitHub, right? So far, this is just one repository. So potentially you can have many. In my case, you see, I have many repositories. There's a place showing repositories. Okay, so there's many repositories you can see. Okay, so you want to anticipate the same thing for you, right? So you're going to have many repositories. So what you want to do then is you want to have a folder maybe on your local computer. Okay, so that folder will match your GitHub account. Okay, say I go to my I'm just go to my documents. Okay, say so my documents. Okay, now I'm back in my documents, right? Okay, over here, then I can create a folder. Okay, mkdir is make directory. Okay, create a directory. Mkdir is like a make directory, and I'm going to call this portfolio, for example. Okay, you can call whatever you want. Basically, this folder I'm creating, this folder is going to be linked to the GitHub. So in other words, every subfolder in the portfolio folder will match a repository on GitHub. Okay, so in other words, let me do this diagram. So on your C drive or your hard drive, you have a folder called a portfolio, or whatever you want to call it, right? And then corresponding to your GitHub account. Okay, now your GitHub account is going to have a lot of repositories, right? So I have a lot. You may have one or two for now. Okay, so one of the project is the Trail app. Say there's a Trail app, right? So that's a repository just for that, right? Okay, so what you need is you have to have a folder under the portfolio, inside the portfolio folder, and this folder will store all the code matches the Trail app. Okay, now if you have another repository for this course as a whole, there's a CSE 248, right? Then similarly, in this portfolio folder, you have another folder that is called CSE 248, something like that. So all the things you put into here will be pushed or synchronized with the CSE 248 repository. You follow me? So now, so basically, this is the whole portfolio folder. So I'm the portfolio. This folder will match the GitHub account back and forth. Okay, so now you always know anything on GitHub is in the portfolio folder. Then anything you want to take a snapshot to be backed up on GitHub account, you know you should put in the portfolio. So that's why it won't be scattered everywhere on your computer, and it's hard to manage. This is just a recommendation. So one day, if we want to share with the people, say, hey, you know, I am working on an app, you can just share, invite someone to be a collaborator to one repository, not all of them. Okay, so that will be a good idea. Okay, so this is the one suggestion. Okay, so here is my I'm making portfolio. Okay, so here's my portfolio. Can I create a portfolio? Oh, I already have one from previous semesters. So I'm gonna remove that. No, I don't think so. I think I have something from last time. So I'm gonna call something different. Make a portfolio for that's portfolio class. No, class is very confusing because people can think it as a Java class. Portfolio say 2020. Okay, so that's my portfolio. Okay, so everything I put in this is gonna go to my personal GitHub account. So I make it put. Now I create that, right? So I create that directory. So now I can cd and go into the portfolio 2020. So now I'm inside that. Of course, if you open it, there's nothing there. Okay, make a list, there's nothing, it's empty. You got it? Okay, now I'm going to link. I'm going to link that repository we created earlier to this location. Okay, I'm going to link there. Okay, so what you can do is you can say git. Okay, that's a git command. Whenever you say git, that's a command. Then you say clone. So you want to clone, right? Then you want to put that the address. Remember that address? That is https/ and github.com/change the instructor, and then I think it's a CSE 248. Am I right? I forgot what it's called now. Trail or something. I think it's for 2020 trail app. Okay, so for 2020 trail app .git. Okay, .git. So this way you make a clone. Clone means you're going to bring all the things down, make a clone. So what that means is you will make a copy of whatever on there to your local computer. So whatever is on there is on your computer, but you don't have access. You cannot make changes. Okay, so everybody can clone. All you need is to be able to read it. Okay, if you make it public, then everybody can clone that repository, because in order to clone, you just need to be able to read. And you make it public, then everybody can read. You make it private, then nobody can read except you. Okay, you're the owner or someone you invite to be a collaborator. Okay, so that's a clone. Now, what this is for? This is for is, say we have a class. We have a class repository. Remember CSE 248 right now, right? And then you could clone it. Then you bring everything down to your local computer in here. Then you can look at the code in there. You know, however you want. Okay, so that is what you can do. Okay, that's what you can do. So I'm going to do clone now. Okay, I'm going to bring down everything to my local computer right now. Okay, I'm going to hit enter. Watch, I'm going to hit enter, and then now it's cloning. You see, it's cloning. Basically, now it's finished. Right? It's not commit. It's finished. Now it's finished, done 100%, and so on and so forth. Now watch. I'm going to do ls. Right? I'm going to see what I have after cloning. I'm going to see what I have, right? ls. You see, now I have a folder. The folder name is the same as the repository name, right? So I'm going to go to the folder and see what's there, right? cd CSE 248 for 2020 trail app. So I'm going to that folder now, right? You see that? Okay, now hit enter. Now you see I'm currently in the folder. And you see the main there? That means you are on the main branch. Well, that's the only branch right now. Okay, so now I'm going to ls to see what's in there, right? In that folder. Now you see there's a readme file. Is that readme file? But what you don't see is the .git ignore, right? Why? Because that file is a hidden file, right? So in order to see that, you have to do ls-l or -a. A means all. You want to see all of the files, including hidden ones. Okay, now I'm hit enter. Now you do see the .git ignore readme.md. Okay, you see both files right now. So that means we succeeded bringing down the stuff we put up onto the GitHub earlier, right? The repository we created, but it's only that repository, nothing else. Even though I have tens of repositories, I've just brought in one. Okay, I brought in one. Okay, now I can use this folder as my workspace. And then any code I write can be can go into this space, into this folder, and then later on I can push it up to GitHub. Okay, so I'm going to show you. Oh, before I show you, I want to do less readme.md. And you see the readme.md has only one line, just say CSE 248.4.2020 trail app. So that's really one line. So I get out of this. There's nothing there to see. Read then .git ignore. Okay, you remember that file that has all the things we don't want to back it up? You see the stuff we saw earlier before, now it's there. Okay, so that proves to you we managed to bring down everything from that repository on GitHub remotely back into local folder. Okay, so now we finally made the match, right? Made the connection between our local folder and the remote repository. Now, from this point on, everything we put into this folder could be pushed up to the repository remote. Okay, now I'm going to show you. Okay, I'm going to start Eclipse now, and just as usual, you write Eclipse code, right? Yeah, starting my Eclipse, and now I'm going to browse. I'm going to browse into that directory, right? That directory that currently has nothing other than the README and the .git ignore. So browse, and remember I said I want to put into the documents folder, I believe, and the documents folder I have a portfolio 2020. You see that? Right now, you see that folder. Right, that's the one I just downloaded. That's the one I just cloned. Okay, so I've cloned that one, and then I use that as my workspace. Okay, then select the folder and then launch. Okay, now my Eclipse is using that folder as its workspace. It's a workspace. There's no Java code. You understand? There's only two. There's only two files in there. There's no Java code. So I'm going to create a Java project. I'm going to say hello world. Hello world project. Hello world. Okay. So I'm going to say finish, and you notice the workspace is this right folder. Okay, module. I don't want to create a module. All right, so there you go. That's my my workspace. Okay, in there, and then now I'm going to create my files now. So I can create a package if I want to. Just show you, I create a package, and then I'm going to write my Java class. And I'm going to say hello world, and then have this, and then I'm going to delete this, and then this is out, and then say hello world. Okay, so I run it, it works, and basically saves it, right? Okay, saves it. Now, what happens now is on your folder, on that local folder, where's my local folder? I'm gonna minimize this, and now ls, and you see the hello world file. You see that folder. So what I did in my Eclipse, you saved it as a folder. That's my project, right? Hello world project. Now it's in my workspace. You got it? That's like a CSE 248 for 2020 trail app, right? Okay, but right now though, there's no snapshots. All I did so far is I added some Java code to this folder. That's all I did. But I haven't taken any snapshots. I haven't made any commit. I haven't pushed this up to the GitHub. Everything now is still at this point, still on my local computer, right? On this location, my documents, portfolio 2020, and then this repository or this particular folder. Okay, you got it? Okay, any questions at this point? So notice we are on local computer right now. We are just writing our code just like we normally do, and we can write anything you want in here. Okay, then it's all saved locally onto this folder, which is known as our workspace, right? It's known as our workspace. Here's my workspace. Okay, up to here, and inside there's a Hello World project, right? That's my first project. Okay, now before I can push it up, I have to mark whatever I want to back up. I have to mark it. The technical word is called to track it. I want to track whatever I want to back up. So you have to mark them to track them. So to do that, you just git, okay, git add means add them to the list to track. Okay, and then you can say dot means current directory. One single dot means current directory. That means I want to track everything in the local directory, or you can just be more specific. You want to track hello world, but usually it's easier just to track everything. Use a dot. Okay, now I'm gonna hit enter. And then it gives you some messages because the format of Linux, Unix, and my Windows in terms of line breaker is different symbol. So it tells you there's a difference in line symbol. You don't have to worry about it. Okay, so now I'm going to commit. Okay, so I track those. I can commit. So git commit. Okay, -m, that's the option. Then you put a message here, and the message is created hello world project. Okay, so you give a message to explain to people, to remind yourself what this commit is about. Okay, initial creation of the project, for whatever you want to call it. Okay, now you hit enter. And now that's marked, and then ready to be pushed up. Okay, so at this point though, a snapshot is taken, and then the snapshot is actually saved onto your local computer. So there's a snapshot on your local computer, and that will be then pushed up to the remote computer, which is the cloud. Okay, good. All right, I'm going to show you this folder now. Okay, I'm going to go to Windows for you to see what's in there. Okay, so go to Windows, you go to Documents, you go to the Portfolio 2020. You see that the application, the workspace, right? Okay, you see that. Okay, and the CBDME ignore Hello World, right? That's the project. Okay, you go to Hello World, you see the library and the binary, and you see that's the P1. You see that class file, that's a bytecode file. Okay, that's the compiled version of the source code, right? And so that's 1 kilobyte. You see the 1 kilobyte? Okay, so now this is the source one. That's the one we wrote, right? And that's P1, and that's Hello World. And then that is a Java file. That's not a bytecode file. It's all, because they're all small, so it's called 1 kilobyte. And that's just the text file. Okay. Now, I also like to show you over here. I mean, let me create this up. How I'm gonna show you something. I'm not that familiar with Windows. I want to show all the used to be here, hidden. Okay. Okay, now let me go back to documents, portfolio, P. Where's my portfolio? Portfolio. Huh? Let me make my name correct here. Portfolio.
I think you made
Yeah.
it hidden. The
I
portfolio to me.
made it hidden. I made it hidden. I know. So I need to. How can I unhide it?
If you click
Maybe under
view at
view.
the top of the Explorer,
Yeah.
that should be an option there.
Where?
At the top,
Yeah, if you go to view,
hit view.
View.
And
Hidden.
and
then
then it
hidden
says hidden
items
items
over on the
under
right.
item checkboxes.
Item checked.
Oh
No,
no, go down two from
Yeah.
there.
Hidden
Yeah,
items.
there you go.
Ah, so I want to change this back. I'm sorry. I don't use. Okay, I want to hidden. I have to use hidden. But what if I want to hide? What if I want to show view? I think that's what it is.
It should be okay now since you have hidden items checked
It's
now,
here,
so it
right?
should apply for everything now.
Hidden items. So okay. Ah, now it showed up. You see the dark gate? That was hidden before. Now it's unhidden, right? So you go in there. Okay, go in there. You see this stuff, the objects. These are the place that the snapshots are stored. So this is a local repository. This is a local repository. All the snapshots are stored. So you could just use a local repository without using GitHub by downloading that Git software we did before. So you could just do that. So in other words, it's not required to use GitHub. That's just a service for you to back up stuff. You don't have to have it. You could just use local. So you can already do everything on your own computer without GitHub. Okay, but the problem with this, of course, is dangerous because if you lose your computer or you lose your hard drive, then you lose everything, right? Because you're not back up off-site. So that's why it is important to use GitHub. Also, if you put it locally like this, obviously it's only good for yourself to work on the project. If you have a team, this is not a solution, right? If you have a team, you have multiple people working on the same project, then you want to put the project onto a central location, then everybody can access it, right? So, but if you're just one person, you want to do it yourself, then this is fine. You can just put in a local. But again, it's dangerous because you lose hard drive, or lose the computer, you lose everything. Okay, so that's why this is a local place. Okay, so you know. Okay, so this local repository is usually hidden, so you don't really see it. And then this is coming from this repository we pulled down before. And the metadata is some metadata file to record all the changes or record any actions we did. Okay, let me go back to here. So far, I ran two things. One is git add ... right? Means to track whatever I want to back up, right? To put in the repository. And then the second step I did was I used git commit and then followed by -m, then followed by double quotes to specify what is the purpose of this, and then do an actual commit. Meaning commit means to make a snapshot. Okay, at this point, once I finish this, all this my code, all the folder now is backed up into that .git folder, that local repository. Okay, So right now, or at this point, already made a backup, but unfortunately, well, not unfortunately, right now the backup is on my local computer. Okay, has nothing to do with the GitHub on the server on the internet. Nothing. Okay, until now, the next step is the step you're gonna actually push the local snapshots to the GitHub repository. Okay, that's how you do it. Push, git push, git push. Now, if you're using this the first time, you may ask for your username and password. So GitHub knows you have the privilege to do it. You are the owner, or you are a collaborator. Right? The first time we'll ask you for username and password. But since we've done this for a while, so it doesn't really ask me anymore. My local computer remembers my privilege. So now you see the thing went in. Okay, went to the remote repository now from my local repository. Okay, now I'm going to go back to the remote location now. Okay, go back to my remote location, which is here, right? Remember that? And then you see that's my repository. Now you see that new folder. We didn't have this before on the server on GitHub. Now I have that. Okay, I click on this. You see there's a P1 and the source, right? When I click on this, you see hello world.java, right? But you don't see that bin hello world class. You don't see that, right? Because that one is ignored. It was ignored because that name was in that .ignore file. Okay, because that's what we wanted. So we have this, and then if you want, you can continue to open up, and then you can see this whole code, right? We wrote earlier, hello world. And then if you go back to history, you go back to history here, and now you notice that we have another. We should have another commit. This is committed 9 minutes ago. That's not the one I'm talking about. Hold on 1 second. I should have 3 commits now. You see, these are the 2 old ones. We showed you this 2 old ones before. Now this is the most recent one. That is 9 minutes ago when I made a commit locally. Okay, so this is uploaded from local. So see the message? Created hello world project. That's the M -M. So is identified in here. Okay, so so that's backed up, and then you can always download it from anywhere as long as I have access to the internet. And then I'm going back to my local computer. Okay, and I'm going to make changes here. So this is out just like normally by world. Okay, so I'm making new changes to my code, and I save it and run it. It works. Then that's all fine. So I'm going to minimize this, and I'm going back to my Git. Okay, I'm going to go back to my Git again locally, and I'm going to say Git status. So that will show me what's my status right now. Okay, what's my status? And I hit enter. Say, hey, there's something changed, but you haven't taken snapshot yet. Okay, there's something different. So it tells you that on branch main, that's the only branch. There's only one branch main. On branch main, your branch is up to date with the original main. So right now, your repository, your local repository is the same as the remote repository. Okay, which is true because I haven't made a new commitment to my local repository. So that both are up to date. However, there are changes not staged for commit. So changes like I add the by world, right? The changes there. So you can use this add to edit it, to update it, or you can restore to discard the changes and going back to what it was. So you can go either forward, okay, to mark them, to take a snapshot, or you can go back, say, I want to discard the changes without taking any snapshot. So I can just go git add and start. So start like a period. So what it does this, will mark every file to be tracked again. So every time I happen to mark files and folders I want to track, so I just did this again, hit enter. Now that did it. Okay, no complaints, is good. So git status. Okay, I'm going to look at the status again. So this time it will tell you on branch main is already the same because we haven't committed anything new. That tells you my local repository and remote repository are the same so far. Why? Because I haven't updated my local repositories yet. Okay, I just marked those changes, but I haven't committed yet. You see, so changes to be committed is this one, and then you can go back to restore. Okay, so I'm going to commit now. So as a git commit dash m added by world. Okay, so I added that. So that's a new message. Hit enter. So now I took a snapshot and stored that into local repository. Okay, which is different than the remote. Okay, so now I say git status. Okay, then tells you on branch main. Okay, your branch is ahead of original main by 1 commit. That means your local one, that's my branch, is ahead of the original main. Origin is the one we cloned. That's the one, the remote, in other words. Origin is the remote. So that means my local one is 1 commit ahead of the remote one. It tells you that my local one is more up to date and my remote one is behind. Okay, so I can keep on adding more if I wanted to. Okay, or I can just push my local commit to remote commit, or push my local repository to the remote repository. Okay, now at this point it says nothing to commit because everything has committed. All the changes, the new updates, they have already committed. So the working tree is clean. There's nothing messy. It's all committed. It's all snapshot taken. Okay. So now again, all I have to do is say git push. That means I'm going to push the new local updates to the remote repository. Okay. So I push that, then it will go there, right? It went there, right? See, okay, it worked. So now let's go back to look at this, and then you will refresh this, and now all of a sudden you have the 4th commit. That's the 4th commit. You see this? Added a by world. That was 2 minutes ago. Okay, and if you want to look at the code, that's a commit history, and then you can go back to hello world, and you can see P1. You can see hello world.java, and you can see the change I made, most recent change I made, and the by world is also is also backed up there. Okay, so this allows you to have a backup of everything you do on your local computer. So even if you lose your computer, lose your hard drive, everything will still be there. You can download and clone again to your local computer or pull again into your local computer. Okay, so that's why it's such a wonderful tool everybody uses. Not just the programmers now, there are people use this as a web server. Okay, because you can upload the web pages to this location, to your repository, to serve as a web server. So people use a browser can look at your web pages. So this is a wonderful thing because when you look for a job, or when you look for, say you're applying for some schools, you want people to look at your work, right? Sometimes not only you put your code up to on the repository for people to see, but you also put your resume, your CV, right, resume, onto GitHub as well. So people can just go to the repository and pull up your resume, and the resume could be written in such a fancy way like in using HTML and then CSS and then JavaScript. It's just like the web course. If any of you were looking at that, one of the assignments was build a personal web page. Remember that, Chris? Right? He's asking you to simulate another programmer from a developer from the Netherlands. I think it was a little cute website, like a personal website. So normally if you want to host a website, will cost you say $50 a month, right? Maybe a little less. 30 minimum. Okay, you have to get a domain name, you have to get host company, you get a DNS set up, and so on and so forth. But if you want to spend nothing, right, you can just use GitHub account like this to create a repository to host your web pages. I think the instructor Angela, she had a demonstration of using GitHub as a web server. Does that ring a bell to some of you guys? You notice? Yeah. So
Yeah.
that's what, yeah. So so that would be our lecture today. Next time we'll come back to this point, and then we're going to learn how to manipulate this. For example, if we want to create a new branch, to have a new timeline, to work on the new branch until we are happy with the new branch, we're going to merge with the main branch, right? Also, we learn how to revert back to any time in history. Say I want to revert back to goodbye. Oh no, hello world. I want to discard any change of the last commit. Then we can revert back, and then we can have multiple people working on the same project on the same repository, and then working on the same file even. You all work on the same hello world class, and then when you're ready, you can all merge them into one copy. Okay, so these are the things that you are able to do with GitHub. So it's very, very, very powerful, very useful, obviously. So I would like you to kind of review this at home and see if you could push your project, okay, up to your account on GitHub, and then play with it. And then next time you'll be ready for the next part of the lecture. Okay, any questions? No questions? Okay, don't forget, we don't have a class tomorrow. Okay, so that would be a good time to work on your stuff. And then I see you on Wednesday.
Bye,
All right,
Professor.
cool. That was really helpful. Yeah.
See you next time.
Good.
You too.
Thanks.
Bye.